Hi, I'm Oscar.
Hi, I'm Erwin.
Erwin, you have some content for us today, and it's about rate limiting.
Yes, that's correct. We're going to talk about rate limiting in .NET 7 because it's still in preview, but with .NET 7 they introduced rate limiting out of the box.
Okay.
And, yeah.
First question, of course, what is rate limiting?
So rate limiting is basically the concept of limiting access to a certain resource. So it can be a database, can be an API. You can do that for different reasons. For example, a resource can only handle a certain load at the same time. So you want to limit that to prevent DOSing of it. Or, for example, if you have an API that you bring to the public and have a licensing idea about it. You want, if someone pays, to have more access to it, but people that don't pay it to have some free usage of it.
So two scenarios, just sum it up so I can understand. One is outgoing as a client. I want to prevent that I'm doing something absurd to the outside because I know I'm limited there. So let's go into some, maybe like a circuit breaker pattern or whatever to do something else or postpone those events. Or to actually keep your audience or your users from your API out, for instance, which is what we know from API management. For instance, if you want to protect an API, it's like I want this client to be able to make so many calls. But this is a bit more like one level down. This is the actual components where how you could build something like this yourself.
Yeah, you're correct. API management does all this, but API management is like a scale above your containers, app services, everything. Now it's also in .NET 7 itself and ASP.NET itself. So you can do it in the code, and so even if you're not using API management itself, you can still have some rate limiting.
And you could always build this yourself, of course. For that you need some state. You need to put some, count how many requests were in and do some locking. But there's now a smart component and it's shipping with .NET 7, you say?
Yeah.
So new bits.
New bits, yeah.
Okay, cool. Can you show us how that would actually work in a real life application?
Yeah, so I made a small demo application. It's just a .NET new API. So the mentioned weather forecast ID thing.
They're still doing that in .NET 7?
Still doing it. So let's start. You have two different packages. First one, the system threading rate limiting. That basically holds the code for it. They have different algorithms implemented. We go through them in a minute. And besides that, there's also the Microsoft ASP.NET Core rate limiting, which helps us set up rate limiting in the middleware policies and
so
some
one is
extra
the
helpers.
Native component from .NET that will help you, I can imagine all kinds of types of rate limiting. That's really in .NET itself, and the other one is in the ASP.NET library side, so it's web hosting.
Yeah.
Okay, and that's talking to the other one. So
yeah.
Okay.
So what I have here is just the normal
the weather
forecast controller. So I just have first off just like manual rate limiting. You probably don't want to do that like this in code, but just to see how it works. So what I have here is just the 4 different rate limiters we have. So let's go through them one by one. First one is concurrency limiter. It's basically you say I give you a number of permits. Permit is like how much requests it can handle. And for this one, it is when a request comes in, it gives a permit out, and when the request is done, it gets the permit back. So it basically says
like a lease construction, right?
Lease, yeah. So at this point, it says we can only have 10 requests at the same time. Next one comes in, it gets rejected. You also see the queue limit. It's basically, they also added it to it, so you can have a queue limit of 10, 100. So it basically means everyone that comes in and requests a permit, but there is no permit available, gets put in the queue if there is room in the queue, and it waits in the queue until a permit becomes available.
Okay, so you don't get the, there's no room straight away? you get a maximum time in queue.
Yeah.
It's like if those 10 are still all using, like after, in this case, what is it? 10 seconds, you get kicked out of the queue. It's like you can wait, but it's not very useful to wait. But if within that time limit, one of the other permits is gone, or actually the request is done, you will actually get a next spot.
Yeah.
Okay, so there's a bit of a back off kind of trick there.
Yeah, and then they have two orderings for the queue, like oldest first, newest first. Depends on your use case. So this is the simplest limiter they have. The second one is the fixed window rate limiter.
Yeah.
So that one is just also we specify window. So a time period can be anything from seconds, days, hours, and we specify how much permits there are in that window, and then. After the window has fully elapsed, so if it's 1 minute, then after each minute, all permits become available again. So it's not like the first one that it gets the permit back when the request is done. No, it just gives it to the first 10, the rest goes to the queue, and then after a minute it gets 10 new ones and it can give them to the first 10 in the queue.
Okay, so in that window you can come in with 10, after those seconds you free up. But like requests that are still there, let's say your request take longer than your window.
Yeah, so
they will stay. It's just making sure you create the manual bottleneck to feed data in.
It's just at the entrance we check it, and if the request takes an hour after that, that's no longer rate limiting. That's area. That's
just a performance problem.
Yeah.
Okay.
So the third one is the sliding window rate limiter. It's basically the same as the fixed window rate limiter, but sliding. So what they did there is you have an extra option called segments. So you can specify the number of segments you want, and it basically cuts up the time in that number of segments. So in this setup, we have a window of 1 minute with 6 segments. That means 10 seconds per window. And it keeps track in the background, like in which segment it gave away the permits. So if in the first segment it gave away 2 permits, and then in the second segment none, and then third one it gave.
So it knows there's still room in the total
so it
window.
knows, and then it's not that after the full minute everything is replenished. It checks per segment. So after each 10 seconds it clears out the oldest segment, and then and it will never exceed the total permit limit, but it lets like smaller buffers.
So again, a manual bottleneck, but with even more granular. Like you can hold the queue for a while. Like it's a bit more safe, and you get a bit more load balancing because of that. Yeah. Because indeed, if you have a while, that like a segment without anything in there, it's also not counted. Yeah. Well. The second option was still just dismissing requests once in a while. Okay. Awesome. And what the fourth?
Yeah, fourth one is a bit different.
It's the most complicated one, right?
Probably, yeah. It's a token bucket rate limiter. So it's the only one where they use tokens, but it's basically the same idea as permits. You can describe it as there's a bucket with just 10 tokens in it, same as with other ones. Someone comes by and it gets token. And what you do here, instead of everything replenishes after a certain time period, you say, I have a replenishment period, and I specify how much tokens should replenish after that period. So in this setup, it basically says every 10 seconds add 1 token back in the bucket. When it starts, you have 10 tokens. So the first 5 requests come in, there are only 5 left. 10 seconds pass, now you have 6 tokens. 10 seconds pass, now you have 7 tokens.
Okay, but we'll never go
over the 10.
Yeah, okay. So we're not overfilling the bucket with tokens.
No.
Okay, so none of them actually specifically limit the durance of the request. There's no, I'm in a request and I'm out of the request, here's a slot back.
Yeah, that's only the concurrency limiter.
That's just the concurrency limiter.
Yeah.
Okay.
So, so if you have any of those limiters to manually call them. It's just an acquire async. You get the lease back, so the lease holds is an object that holds the information if something is acquired. So there's a super easy if check here, like is acquired, no, then just throw an exception, do something. Else we can just execute code.
Yeah.
Besides that, what you see in this example is it's really basic, as all limiters go on all requests, but in practice we probably want to differentiate between IP address, logged in user ID.
You want some kind of partition almost.
Yeah, well, that's the correct word.
Oh, okay.
Because we have here the partitioned rate limiter.
I really didn't know that.
So basically it does the same, but creates the rate limiter in a certain partition. So this is really basic setup where we just we get the HTTP context. HTTP context holds all kinds of information, and even if you are authenticated, or your IP address. So we can just in this case
context from the one requesting it. So IP address makes sense for an example.
Yeah. So in this case, we take the IP address and then we return just a token bucket limiter for IP address. So if we call from that IP address, it gets 10 tokens. But if you call for a different IP address, it also gets a bucket with 10 tokens. So then we now limit it.
So everyone has their own limit in the end.
Okay. And then, what does that change in code? Instead of the normal acquire async, we now have an acquire async, and we have to pass in the HTTP context. It doesn't have to be HTTP context.
No, but like something you define there.
It can be string, can be anything. It's just a type.
You create a rate limiter with a generic type in there, and that's the one you're expecting on the actual acquire.
Yeah.
Okay, cool. So this is a bit different scenario. Like some of them are really like deny all service, like keep everyone out, and the other ones like it is what you would implement for what you can do with API management, for instance. Like all the free plans can only do like one call a minute, or what you also see on Cosmos DB, for instance. Like on that instance, like you can only request this for this DB or for this. Interesting. So to see those scenarios. So this is really incoming.
Yeah.
Okay, but you said this is manual. So this is out of the box raw. You insert some kind of limiter. You need the state for that. But this is the package from .NET Core, so the base. And you told me about the ASP.NET. So it's somewhere packaged for you, I guess.
Yeah,
made simpler.
Yeah. Like you probably noticed from other stuff you can inject in middleware. We just have, if you have the second package, the ASP.NET Core rate limiting, you have add rate limiter
so
with some options.
Basically DI with how you want to set this up.
Yeah, you can pass in three things: rejection status code, just HTTP response code you want to send back. The unrejected, so what you want to do in an unrejected call. So in this example, you get the unrejected context, so you have the full HTTP context, who did it, but also the lease that was tried to be acquired. You can figure out, so in this example we take out the retry after header and just print it out like, retry again after 1 minute when the bucket has been refilled. Basically.
Yeah, this is what you see sometimes on an API what you're playing with, especially like if it's a sandbox version. It's like here's a 429 and try again after 10 minutes. Or okay, so you built that in 3 lines of code.
Yeah, so all that context is there in the unrejected method, and then you have the global limiter. So global limiter is basically if it's set, it's the limiter that's always checked. And you can also specify more limiter and add policies.
You can also combine them. Yeah. It's not just putting one in.
No, it's one. Like if you look at this one, there's like a helper function, partition rate limiter, create chain. So we saw the partition rate limiter create for creating the partitioned one. The create chains is actually for chaining multiple ones together, hence for the name. So in this example, basically we have two fixed window limiters, but like we say, like you have 1,000 requests per hour for your IP address, but only 10,000 per day.
Yeah.
And so you can
stack
combine.
them.
It doesn't even need to be the same type. You can have a token in there, concurrency limiter in there.
But it's like your middleware stack. It's just going through one. Like if one cancels you, it doesn't even have to evaluate the other ones, of course. Cool. And do you get which limiter it was that kicked you in your actual middleware or exception where you're throwing?
Yeah. So that's in the lease. It tried to
that's in the
take,
lease.
and that's it. That it has that information.
Okay.
So you have the retry after knows if it's for 1 hour or for 24 days apparently.
Yeah, indeed. Because if you make a weird combination, like I guess debugging is going to be fun.
Yeah.
For this stuff. So this is where you do your ads on your services. So this is DI, so the limiters can be injected or are somewhere on the stack. Do you need a use then? Because that's the normal pattern.
Yeah, that's down here. Just use rate limiter. As you see here, we also can add different policies. So I created a custom rate limiter here. Then you can just add by policy, and then we can, I think, require rate limiting, and can we just pass in the policy name, and then now everything uses that. Doesn't make much sense here, but if you, for example, have different API endpoints,
in this case.
And So
also in this case, like not everyone has that sharp. Maybe you see you add Swagger in Swagger UI. Before you do the rate limiting, that means that they're on the middleware stack and get picked up first. So Swagger isn't rate limited in this case.
That's true. But like that's one way to call it. You can also on a controller itself, just like role-based authorization, basically also have enable rate limiting with the same policy
so it's
name.
either everywhere on the stack or like this bit filter.
Yeah, on the controller, on the method, you can put it anywhere. And there's also one, if you say, okay, I don't want it here, this one should be always available.
I think the pattern is pretty recognizable for indeed authorization. You can like invert it as well and put it granular where you want it.
Yeah.
Okay, and that's then, can you scroll up a bit? Because I'm now curious. Do you need to define which limiter you get? Because the other one, we're just injecting policies.
This one, you mean?
No, on top on your controller you had one.
Yeah, so this is policy.
Just the policy name.
Policy name. So in program, here you say add policy name with this rate limiter. This is one. There's just an interface. I rate limiter policy.
Yeah.
You can just create your own policy here. So basically, I checked here if it's localhost, no limiting, else throw a fixed window limiter in it.
Okay, and then you can, what you can do then, of course, is get one of the existing limiters to use, but with some extra scenario.
So a good idea here would be like, is someone authenticated? Then you get a much bigger limiter. It's not authenticated, then you get a much smaller limiter.
Cool. This is really interesting. I don't think this is for everyone, is it?
No, like you really need to have use case where you have an app service or something and say I need rate limiting there, and not like on a broader level for like API management.
I can imagine it, like if you're doing some homebrew of things, and it works, and as an inbound limiter or really specific scenarios that you want to even like API management grants us this, but I really don't want you to DDoS or rotate token endpoint or whatever, things like that. It definitely has a place.
And a good thing to remember with the current implementation is the limiters they have right now, they all have it in memory, the token thing. So if you have an app service and, for example, it scales out, the second app service is as brand new rate limiters there. Yeah,
I didn't even go into that, but the rate limiter itself is like your memory cache. It's just there. It's in memory. So scaling out won't help you for any customer scenario that you want to limit them, because you won't be able to know. And like if the app gets reset or something like that, you start by 0.
Yeah.
There's no hook in there that you can, like, where to put your storage, or
well, no,
not yet?
At this point not. They have, like, all the limiters are inherited from rate limiter class itself, which is just an abstract class, so you can of course write your own limiter there that has some external Redis cache, puts it there, but it's not coming out of the box right now.
You don't want some external storage interfering in that pipeline, because IOing for everything coming in is like you already have built a limiter because of the performance bottleneck you're throwing in there. So I can imagine it's also complicated. But like on startup and sharing some state might make sense. We built this by hand a long time ago in one of the applications, and you've seen that code base. This is like identity. You shouldn't do this yourself. And if you can prevent you even using this and then using a service, I think most cases better. But it's good to have this option, because now it's either throw API management in front of it or something like that, or completely build your own. And it's cool. I like it.
Yeah.
Thank you for that information.
Yes, you're welcome.
Thank you for watching, and see you next time. Bye.
Bye.